Okay, hello everyone. Let's go ahead and take a look at integration. And what we're going to do is we're going to start off by looking at anti-differentiation first. And remember that we said that anti-differentiation actually yields a family of functions because of the fact that when we anti-differentiate, we also come out with the C, which is the constant of integration. So here's all of our rules, and I think all of these should be pretty familiar with everybody. We have the constant rule, the power rule, scalar product rule, sum and difference rule, our exponential rule, and our logarithmic rule. Okay, and then notice that what we have here again is that if this is our original function, then the capital F of x, of course, is going to represent the antiderivative, or what happens when we anti-differentiate this particular function here. And remember we said that if we wanted to go ahead and check to determine whether or not this is actually true or not, we can go ahead and take the derivative of this and determine whether or not we actually come up with that as well. So, there you go, there's all of the rules that we have. I'm sure that all of you are very familiar with them already. So what we're going to do is we're going to take a look at what the relationship is between the antiderivative and the integral. Okay, and now integration and anti-differentiation is basically going to be the same thing, except for that the notation is going to be very, very different. Okay, so notice that with integration, again, we are also going to be yielding a family of functions because of the fact that what's coming out of this is actually a function. So if we go ahead and take a look at the relationship between these two, let's say. Here we said with anti-differentiation, if we took f of x equal to 0, if we anti-differentiated that, then f of x would, capital F of x would be equal to c. Now, if I wanted to take this exact same idea here and use the integral notation to go ahead and show that relationship, I would just say the indefinite integral of 0 d of x is going to be equal to c. Okay, so notice that what I'm coming out with is the antiderivative itself. So now the other one that we want to be careful of is this one here. This one usually causes a lot of difficulty because it looks so odd. If we take the integral of d of x, then we actually come out with x plus c. Now let's just go ahead and double check to make sure that that's correct. If we go ahead and integrate x plus c, what do we come out with? We just come out with 1. And notice that there is a 1 in front of here that we don't write. Okay, so we know that that's okay as well. Now, with the power rule, let's just go ahead and take a look at it from here. We say the integral of x to the n d of x is going to be equal to 1 over n plus 1 x to the n plus 1 plus c, where n is not equal to negative 1. So notice the result is exactly the same here. It's just the notation that's different. Okay, and so you can go through all of these. They're all going to be the same. Scalar product rule, right? Notice that what we have there and what we have there as a result is the same. Notice that what we have here for the sum and difference rule is exactly the same. It's just that the notation is different. Here again, exactly the same in terms of what we're coming out with as our antiderivative. And notice that we also come up with the same thing here using the integral notation. So, hopefully that makes sense as to how these two are related to each other. Now the one thing that we want to do is let's just go ahead and take a look at an example. And just make sure that we know how to actually do this with a particular function. So let's just say, for example, that f of x is equal to 2x. Now if I wanted to go ahead and find the antiderivative of that, the antiderivative of that is actually going to be the same thing as the integral of 2x d of x. Okay? Now if I wanted to go ahead and do this, this is x d of x. Now once I go ahead and do this, which rule do I use? I go ahead and use the power rule. Okay? Because I know that the x1 is 1 and it's not negative 1. So this is going to be 2 times 5 is 1/2 x squared and then plus c. So what I'm coming out with, the 2 and the 1/2 will cancel. That's just x squared plus c. So I know that the antiderivative is just going to be equal to x squared plus c. Okay? Now, what we're going to do is we're going to call this the general solution. Okay, and the reason why this is called a general solution is because we are referring to a family of functions. It's a general solution. It doesn't necessarily give us one particular function because c could be any number that we want it to be. Now, how do we go ahead and solve for this value of c? Well, in order to do that, we need more information. Okay? Because if we go ahead and think about what this is as a graph, let me just go ahead and do this very quickly here. If this is the x-axis and this is the y-axis, then if, say for example, c was equal to 0, then I know I can come up with something that looks like that. That's my parent function for the parabola. But what if c was equal to -1? Well, then that parabola would just shift down 1. What if c was equal to 2? Well, that parabola would then shift up 2. So notice that what's happening then is we're coming up with a family of functions, and this c then will actually represent a vertical translation. Now the question is how much do we vertically translate to come up with a particular solution from the general solution? Well, we cannot determine that at this point. The only way that we can determine it is if a particular point on the curve is given. So let's say, for example, that in addition to this information, I know that the point 2, 8 is on the function, on the graph. Now, if that additional information is already given, then what I can do is I can actually go ahead and determine that. Well, it says that if I take a look at f of 2, capital F of 2, this is going to be equal to 8. And so what that means then is if I substitute the 2 into here, this becomes 2 squared plus c is equal to 8. 4 plus c is equal to 8. Therefore, c has to be equal to 4. Therefore, what I can say then is that the antiderivative is actually going to be equal to x squared plus 4. Okay, and this now is no longer a general solution, but a particular solution. Okay, because I no longer have a family of functions, I have one function. Okay, so that's the process that we also need to understand in terms of what c is actually representing as the constant of integration. Okay, so hopefully that made some sense to everybody as to how we can actually look at antidifferentiation, see how that relates to integration, and how it yields a family of functions, and it provides us with a general solution to the for the antiderivative. And if you're given a particular point, then you can find the particular solution that satisfies that equation. Okay, so hopefully that helps you out. Let's go ahead and see if that makes sense. And if we have any questions, we'll go ahead and ask them in class. Okay? See you next time. Bye.